Hi there, welcome to my practice questions on being able to solve simultaneous equations using the elimination method. What I'd like you to do now is to pause the video, have a go at the three questions, and then when you're happy with your answers, restart the video and go through the model answers with me. So pause the video now. Hi, welcome back. Hopefully you've attempted these three questions now. Let's go through them together. Question 1. We've got a simultaneous equation here. And the first thing to do when we're using the elimination method is to make either the x's or the y's the same. Now that's already been done for us on this one because the y's are already the same. There's three of both of them. Then we check the signs in front of them. If the signs are different, which they are, we add the two equations together. So we're going to add these two equations. So we need to add each term individually. So 4x add 2x is going to give us 6x. And then minus 3 add 3 is nothing, so I've eliminated the y's, and minus 1 add 13 gives me 12. Once I've done that, I solve this simple equation by dividing both sides by 6, and that's going to give me x equals 2. Then what I do is I substitute my value for x back into the first equation, so I replace this x now with 2, so I could write down 4. Let's use brackets to show times 2 minus 3y equals minus 1. Well, 4 2's are 8, so 8 take away 3y equals minus 1. Then take the 8 away from both sides, so you're left with minus 3y equals minus 9. If I then divide both sides by minus 3, I'm going to be left with y equals 3. Because minus 9 divided by minus 3 is a negative divided by a negative, which gives a positive answer. Question 2 then. This time I'm going to have to make one of these, either the x's or the y's, the same. It's not done for us like it was in the first one. Well, it's not very easy to make the x's the same because I've got to multiply 3 by a decimal or fractional number. But the y's I could do easily by times in equation 2 by 2. To give me 10x plus 8y equals 78. Check the signs. Cross this one out, we don't need it anymore. They're both positive, so we have to take one equation away from the other. Now, it's best to take the smaller one, this top one, away from the bottom one. It makes it easier because you're not dealing with negative numbers there. So I'm going to write this one underneath. 3x plus 8y equals 29. And I'm now going to take them away. So 10x take 3x is 7x. 8y take 8y is nothing. And 78 take away 29 is 49. Now solve the equation, divide both sides by 7, and I get x equal to 7. I now sub my value for x back into equation 1. So 3 times 7 plus 8y equals 29. Well, 3 7s are 21, so 21 plus 8y equals 29. Now solve the equation by taking 21 away from both sides, which will leave me with 8y equals 8, and then divide both sides by 8, so y is going to equal 1. Okay. Number 3 then. This time we've got both the A's are different, the B's are different, and also it's very difficult to times this by one number to get to 5a or to times 4 by one number to get to 7b. They both have to be fractions. So we're going to multiply both equations now and change both of them. Now generally I usually like to multiply the equations that have the different signs here. It makes it easier because then you end up having to add the two equations together. I'm going to do it the other way because some of you always like to start with the a, so I'm going to try it this way this time. So what I'm going to do is I'm going to multiply the top equation here by 3, and that's going to give me 15a. So in order to get 15a, I'm going to have to multiply the bottom one by 5. So we're changing both of them. So 5 times 3, that's 15a plus 21b equals 192. And then this one becomes 15a minus 20b equals 110. So because the a's are the same, the signs are the same, we have to take one equation away from the other. So be careful here, because 15a take away 15a is 0, but 21 take away negative 20. Let me just write this here. You've got 21 and you're taking away negative 20. So here we've got the two negatives, which is going to make that into a positive. So this here gives me 41b is going to equal 192, take away 110 is going to equal 82. So if I then solve this equation by dividing both sides by 41, I'm going to be left with b equals 2. But be careful with these negatives here. Then I've got to sub b back into equation 1. Let's just write this over here. So I get 5a plus 7b, well b now is 2, and that equals 64. So 5a plus 14 equals 64. I now solve this equation by taking 14 away from both sides, which is going to give me 5a equals 50. If I divide both sides by 5, I'm left with a equals